In this recording, we're going to talk about quadratic functions as area models. So I think you know area, length times width, right? As long as we're speaking about a rectangle. So go ahead and find the area of the following rectangles. Play the recording when you're ready. Okay, so hopefully you paused and worked these out. You found that 5 times 20, and there's lots of ways you can think about 5 times 20. But that does come out to be 100 square units. And now we're thinking about 8 times 25. Again, I like to think about money when I'm multiplying by something like this, because 25, I can think of quarters, and 4 quarters make $1, so 8 quarters makes $2. I'm talking about 200 here. Okay, so we like to have flexibility in our thinking so we can kind of work some of these out using mental math. And of course, what would it be if we know the area, we know one of the sides, but the x is unknown? So take a moment to figure out what x has got to be. All right, and hopefully recognize, oh, x has got to be 5, because 5 is the number times 20 that makes 100. All right, so a good little warm-up for you. Now let's complexify the situation a little bit, if that's a word. Let's complicate things. So now we've got sides that aren't numbers. In fact, they are algebraic expressions. But we can still apply that same idea of multiplying length times width and finding that area in terms of x. Okay, so we're going to have an area that's an algebraic expression. So if you recall, we like to set this up with a window, right, to represent the different components of the length and width that aren't like terms, the x and the 3. Okay, so go ahead and set this up and try to simplify the terms that result in the expression in the window panes, and then write your area here. Play the recording when you're ready. Okay, so hopefully you ended up with an x, 3, x, and a 1. If you haven't worked this out yet, please do it so on your own, and then play. We're going to combine like terms on the diagonal. Okay, so that's our area in terms of x. Let's raise the bar a little bit. What if I want to find the area of a shaded area? And that's what we're going to end up doing in part 3. I want to find this kind of lighter gray zone, but that's not the entire rectangle, right? So I have to kind of work with the big rectangle and the little rectangle to find the shaded area. So I guess if you could you find the area of the larger rectangle, this says in part 1? Could you find the area of the smaller rectangle? Of course you could. So be organized, and then see if you can subtract the answer from part 2 from the answer from part 1. In other words, your little white rectangle, can you take it away from the overall rectangle? Play the recording when you want to check your answer, or if you need a hint. All right, so hopefully you worked this out as far as you possibly could. Okay, so that's step 1. I know some of you did not do any more. All you did was copy down what I had on the screen. Pause and actually work this out on your own. Don't play the recording until you have tried to find the area of the smaller rectangle in terms of x. Okay, remember when we find an area, it's just a length times a width, right? So we have these two different products that we have to create, right? 2x times x, 2x squared, 2x times 2. Essentially, we're distributing, right? I think about it flexibly. All right, now these aren't like terms. Let's write them separately. Okay. See if you can finish this out. We have the two areas, big rectangle, small rectangle. Can you find the shaded region's area? Play the recording when you're ready. Okay, so we want to subtract from. This is a subtract from problem, so I have to subtract the smaller from the larger. Okay, the way I like to approach this is distribute that -1 to both those terms and rewrite it. Okay, we make very much fewer mistakes when we do addition than we try to keep track of our subtraction. Now it's just a matter of combining like terms. Well, that's kind of a funny looking area, right? Because it has a negative sign in it. But of course, this is just the result of different side lengths being in terms of x. Okay? Finally, your turn. See if you can work this one out from start to finish to find the area of the shaded region. Play the recording when you're stuck or you like an answer. Do not play the recording until you've pursued this as far as you possibly can. Okay, let's see how you did. Hopefully you were able to get something here. See if we can work this out together. Okay, so there we have the area of the overall big rectangle. Now let's find the area of the smaller interior rectangle. Okay, so now to find the shaded area, we need the overall minus the white. That's the overall minus the white. Those are opposites. Here's another pair of opposites. So the only terms that are left are the 8x and the 2x for a sum of 10x. All right, the final question I would like you to consider is this one, where we want to find the dimensions of this triangle. We want to find the overall length of this triangle, of this rectangle, the overall length and the overall width of this rectangle, knowing that the buffer all the way around, or we're going to make the assumption that it's all the way around. This side is a 3 as well. Okay. The buffer all the way around is 3. So can you state what the length and the width might be in terms of x? Play the recording when you've got a thought about it. So hopefully you considered that a little bit. If I'm looking at this side here, I've got an x plus 2, but then I've got a 3 on either side. So it's really like x plus 2 plus 3 plus 3. Similarly, in this direction, I've got an x plus a 3 plus another 3 on the bottom. So I'm not going to worry about which one's called the length, which one's called the width. That doesn't really matter here, but the point is the dimensions. This side, when I combine like terms, it's an x plus 6. This side, when I combine like terms, is an x plus 8. Thanks for watching.